This conference will now be recorded.
Okay, we are in a day 9 session. In yesterday's session, that is day 8 session, we had a discussion on top of inheritance and we have seen the programs also. And I started OOPS principles. I explained the first principle, that is what inheritance, in my yesterday's session. In today's session, I would like to take one more OOP principle, that is what polymorphism, so that we'll try to understand this. Okay. So as I said, what do you mean by polymorphism? Poly means many. Okay. Poly means what? Many. Morphism or something like, morphism means what? Many forms. Okay. So polymorphism is saying many forms. Okay. One name. Okay. It has a one name. Okay. Can behave in different or can provide different actions. Okay. So especially we are achieving this polymorphism in Java. Okay. Using two concepts. One is method overloading. Another one is method overriding. Okay. So one is method overloading. Another one is what? Method overriding. All right. So polymorphism is saying many forms. Okay, behaving like a single object can behave like, different actions. Single object can behave like differently based on the context. That is what exactly polymorphism is saying. This is the principle. This is the object oriented programming principle. That principle we are achieving by using two concepts in Java. One is method overloading, another one is method overriding. And moreover, we do have two types of polymorphisms are there. Two types of polymorphisms are there in Java. What is those? One is what are those? Tell me. One is compile time polymorphism. Another one is runtime polymorphism. Very, very important. One is a compile time polymorphism. Another one is a runtime polymorphism. So which concept we are using to achieve compile time? Which concept is using to achieve runtime polymorphism? We will see. First, let me start with my discussion about method overloading. First of all, what do you mean by method overloading? So method overloading is the process of defining the method name as same by changing signature. Okay, meaning that method name is same, but what is going to be different? Method name is same, but what is going to be different? Signature is going to be different. Signature is different. What do you mean by signature? Come on, please. What do you mean by signature? It might be number of parameters, number of arguments. You may change number of arguments or type of arguments, or at least order of arguments. You need to like what change. When you are changing any of these, so you can say that method is overloaded. You can say that method is what? Overloaded. Yes, you may not understand. For example, public void m1 is there. Here it is accepting one argument of a integer type. Here, if you want to overload, I am not talking about the logic here. Okay, keep the logic as per your requirement. Keep the logic as per your requirement. That's not a problem. And now, if you have this method, if I wanted to overload this method, what we have to do? You have to like what? Use the same method name. You have to like what? Use the same method name. Public void m1. And after that, what we have to change? Either you need to change the number of arguments or type of arguments or at least order of arguments. For example, this time, if I'm using float x, meaning that obviously this time this m1 method is getting overloaded or not? Yes. Why? Because of you are defining the method name as same, but you are changing the type of the argument. So like this, you may change the type, or you may change the number of arguments, or you may change the order of arguments. In any case, if you are changing the signature, okay, so obviously that method is saying that method is getting what? Overloaded method. Okay, that method is what? Overloaded method itself. So in this way, we have to like what perform the method overloading itself. So we'll see one example so that you will get the clarity. Let me try to like what close all. Okay, don't save. Okay, so now open the test2. Okay, open the test2. Okay, see here. For example, here. So this is my test2 class. This is my test2 class. Save it. Okay, now I define the main method. I define the main method. I have a test2 class. I have a main method. Now, what I wanted to do now, before this, inside this test2 method, I have one method is there, public void m1 intex system.out.println of integer argument. Okay, simply I'm writing one SOP message. Public void m1 of string x. Okay, system.out.println of string argument. Simply I'm writing like this. So tell me, this m1 method is getting overloaded or not? Yes, sir. Because of I am defining the method name as same, but what I am changing, the type I am changing. When you are changing either number of parameters or type of parameters or at least order of parameters, if you are changing, we can say that method is getting overloaded. So obviously this is eligible for what method overloading? One method, different signature. So here the logic is different, here the logic is different. Come on, define the object for this test2 obj equals to new test2. Object is getting created. Obj dot m1 method. If I am passing 100, when I try to run this, immediately we are getting integer argument. Okay, obj dot m1. Okay, Rama. If I am passing string as an argument, because of my m1 method is accepting string also as an argument. That is the reason why you are invoking. One time you are passing integer value, another time you are passing string value. When I try to run this, you are getting string argument also. You are getting what? A string argument also. Now try to understand, this is the basic information or basic program regarding method overloading. How we can overload the method. How we can overload the method like this. But here in overloading, we do have different scenarios, different cases are there. Those cases also we'll try to understand. For example, inside this program, let me take the backup, just an initial program. This is the demo program. Okay, basic program on top of this. After that, I will try to make you understand with some other cases. Let me save this. Come back to here. Come back to here. Now, int x is there. Okay, float x is there here. Assume I'm just removing the string instead of string. I'm just removing the string. I'm just putting the float itself. And along with the float, okay. Now, if you have these two methods, if I am running this m1 of 100, when I try to run this, integer argument will come as usual. Okay, obj.m1 of, if I am passing 3.4 f, meaning that it is just checking whether it is there or not there with the float. Yes, it matches. So accordingly we are getting. And one important point I wanted to tell you. Okay, here in case of method overloading, this method overloading is also known as what? Compile time polymorphism. Sir, you may ask one question, why we can consider this one as a compile time polymorphism? How can you say this is an example for compile time polymorphism? Yes. So now if you are observing this, I am just creating an object. Okay, I am just creating an object. But whenever you are calling the m1 method, okay, on top of this obj, where obj is the reference variable of test2. Okay, object will be created at runtime. Object will be created at runtime. But if you are observing obj, sorry, here I am just segregating this obj. This is also fine, sir, right? The first statement is what? Object declaration. The second statement is what? Object referencing. Object referencing, meaning that you are providing the address. Whatever the object you have, you are providing the address. This is referred to like what? Which object you are mentioning, you are providing. So by this statement, the 19th line is object declaration. So now tell me, this will be happened at runtime whenever you execute the program. But this 19th line is available at compile time only. This 19th line is available at compile time only. Why? Because It is just an after all declaring the variable. Okay. So now if it is available at compile time, obj.m1. So since obj is of test2 type, I am calling m1 method. So control Java compiler will go to test2 class and m1 method is there or not there. Yes, it is there. And 100. So meaning that m1 which is accepting the integer, it is there or not there, it is just checking. The entire stuff is done by whom? Java compiler. So ultimately this method resolution will be happened at compile time or runtime. Okay, will be happened at what time? Compile time by the Java compiler based on reference variable. Based on what? Reference variable. So we don't require object type. We require only the reference variable. If you have a reference variable, that's it. This method resolution will be happened. This method calling is binded with this particular method. This method calling is binded with this particular method. That resolution will be happened or decided by the Java compiler at compile time only by using this reference variable, not based on the object type. That is the reason this is the example for which polymorphism? Tell me. Compile time polymorphism. Because of what do you mean by compile time polymorphism? What do you mean by here? I'm writing compile time polymorphism. What do you mean by compile time polymorphism? Tell me. This is a polymorphism. Okay, where method resolution or binding can be decided at compile time by the Java compiler. Okay, based on the reference variable, not based on the object type. This is a very important and a crucial point. Okay, that is the reason method overloading is the best example for compile time polymorphism. Okay, compile time polymorphism itself. So I hope you understand this. But still, I wanted to tell you few more cases regarding this. Compile time polymorphism, especially. For example, integer is there, float is there. Now, after this, Control A, Control C. This is I'm just giving you after this information. Same kind of example, but for the little understanding purpose, I am just adding few more points here with respect to program. Okay, so different cases we'll try to see. Okay, now you observe here. You have created an object and you are calling. Now obj.m1 of, for example, C I am passing. You are passing what? obj.m1 of 100. Control will go and then check it. Yes, it is there. Java compiler will check for this method which is accepting integer as an argument. Since it is there and it will be executed, that's fine. And in the same manner, m1 method is there. Since you are calling 3.4f, Java compiler will come and then check for this method and it will be executed. But now you are passing C. C is what type? Tell me, all of you. I am seeing your chat box. C, whatever you are passing, this C is of which type? Tell me. It is a character type. Isn't it, right? So now what we need to understand is since C is a character type, okay, but we don't have any m1 method which is accepting character type. But in the initial sessions, I have told you one widening typecasting and then narrowing typecasting, implicit typecasting and then explicit typecasting is there. What do you mean by implicit typecasting? Converting lower value into higher value. That is the meaning of what? Implicit typecasting itself. That means what is the order? Tell me. What is the order? So there is an order, right? I think with respect to typecasting, there is an order. What is that order? One second. Right, sir. So we already understanding about what a widening typecasting here. Typecasting. Okay, 1 second. Okay. So here you see implicit typecasting or widening typecasting, converting lower type value to higher type value. So if you are observing, this is the order. This is the order. Let me copy this and I'm keeping it in the comment line. Here, this is the order. So now you are passing right now a char value, but char is promoted to char is automatically gets converted into integer. So your Java compiler will first check for, do we have any method which is accepting the character? Do we have any method something like that? No, we don't have. Now, if character will be promoted to next level, promotion of which data type will be promoted from character type to what is the next level? Integer. If it is there, yes, it is there. So then when you are passing this character obj.m1 of c, ultimately which one will be executed? Tell me. This method, the method which is accepting integer argument, meaning that even though you are passing character as an argument, that character argument will be promoted. This will be promoted to like what? A integer. This is the method overriding, sorry, method overloading at automatic promotion. Automatic promotion. Okay, that is what you need to understand. So if that is the case, what is the output you are getting? Integer argument, float argument. This will also give you what? Integer argument only. Let me cross check it here. Once if I run this, integer argument, float argument, integer argument. Since it is automatically getting promoted to like what higher data type, since it is there, that is the reason we are getting this. For example, if it is not there, assume if it is not there, I am just keeping it in the comment. Okay, if it is not there, so now you are passing 100, 3.4f. Now tell me, integer is there or not there? Now no. Now it is not there. Int will be promoted to long. Long is there? No. Long will be promoted to float. Float is there? Again. So it will come to like what? A float only. It will come to like what? Float only. So ultimately, this method will be giving you float argument as the output. This method anyhow it will give you float argument, and character also will be promoted to int to long to float. So for everything, this will be only executed. This will be only executed. For example, if I am passing obj.m1 of 20l or else 20l, come on, please tell me. L is there. L is there. So L means what? It is representing long. So long, we don't have any m1 method which is accepting the long value. So long will be promoted to float. So again it will be executed. Again it will be executed. For example, come on. This also will give you integer argument. Sorry, float argument only. This time, float argument only. Okay. Now, if I am passing obj.m1 of 34.56, tell me, immediately we are getting the error. Compile time error we are getting. Why we are getting? Your compiler, Java compiler will check for exact match. Exact match is there or not there? It was not there. Then if it was not there, what it will check again? Any promotions are possible or not. So the highest data type, numeric data type is what's a double. More than this double, we don't have any other data type. That is the reason if any method which is accepting the double type, that will be executed. But since for this automatic promotion is not possible because of double is only the highest data type. Okay, that is the reason automatic promotion is not happening or not possible in this case. That is the reason we are getting what? Compile time error itself. This is what we need to understand, especially while you are performing the overloading with the primitive types itself. Overloading with the primitive types itself. Okay, so let me copy this. So ultimately my conclusion is what? It's very clear. If Java ultimately method overloading or compile time polymorphism is happening based on the reference variable, not based on the object type. whenever you call the method by passing the corresponding value, first Java compiler will go to the class and it will check for that exact match. If that exact match was not there, it will look for the next level data type method. Next level means what? So whether that will be implicitly or automatically getting promoted to the next target, next higher level data type. If that kind of method was there or not there. If that is also not there, that time actually we are getting what type of error? Compile time error itself. Okay, these are all the points you need to like what remember regarding this automatic type conversion, automatic promotion. Okay, method overloading with automatic promotion. So example on method overloading with automatic, okay, automatic or implicit, okay, promotion. Okay, automatically the data type getting promoted to like what? Next level data. If that match was there, that only will be executed. Otherwise, it will give you compile time error. These points only you have to like what? Keep it in your mind. Right. 1 second. Okay, so this is all about what? Compile time polymorphism itself. This is all about what? Compile time polymorphism. But I wanted to tell you one more important point here. For example, if I have a method, it's something like this. For example, m1 of int x comma float y, int x comma float y. Okay, here one more method is there, public void m1 of, okay, float x comma int y. So if you have like this, it is something like, just for your understanding purpose, int float argument, and here it is float int argument itself. You assume if the method is something like this, so meaning that, so first of all, is it a overloading, or did you overload the method or not? What did I say? Method name is same. Okay, method name is same, but what is going to be different? Signature must be different. What do you mean by signature? Whether you may change the type of the parameter or number of parameters or at least order of parameters. So here what we are changing? Here what we are changing? Here the first argument is integer. Here my first argument is float. Here my second argument is float. Here my second argument is what? Integer. That means what? You are changing what? The order. Even though if you are changing the order of the parameters also, order of the arguments also, we can say it is a overloading. Method is getting overloaded, we can say. Yes. So now what I wanted to do is, I'll just, since I took the backup, I'll try to like what, remove all these things. Simply public void m1. We do have two methods are there. This is the overloaded method since you are changing the order of the parameters itself. Now inside this main method, I am just creating the object for the test2. Okay, after this obj dot m1 of, okay, for example 100 comma 24 point f, 100 comma 24 point f. If I run this application, what is the output you are expecting? Tell me. Int float argument or float int argument? So you are passing 100. Okay, you are passing 100. Exact match is there or not there? But along with this, float is also there. Exact match is there or not? Okay, exact match is there. So int is there, float is there. But here the point is, even though you are passing, int is going to be converted into, int will be promoted to like what, float or not? If int will be promoted to float, and this is also the match, right? So exact match is there, sir, int and then float. But this method which is accepting the float, but this int value also will be promoted to float. If that is the case, two methods will get matched. So then what is the output you are getting? What is the output you are getting if this is the case? So since we are already aware of automatic promotion with respect to overloading, but here whatever the 100 value you are passing, this is possible for this method and as well as what this one also, because of int will be promoted to float. If that is the case, what will be the output? If I try to run this application, I am getting int float argument. If I am getting what? Int float argument. Okay, for now obj.m1 of 24.f comma 24.f comma 100 if I am passing. Let me save this. When I try to like what run this int float and then as well as what float int argument we are getting, meaning that exact matches. One second. One second, sir. So now this is working fine. This is working fine. Now obj dot, okay, I am just asking by keeping this one in the comment. Otherwise, you can easily guess it. Obj dot m1 of 10 comma 10 comma 10. Obj dot m1 of 10 comma 10. Now tell me obj dot m1 of 10 comma 10. With that, with respect to 10, do we have any integer? Any integer value? Yes, it is there. And what about this 10? What about this 10? So sir, m1 method is accepting, okay, if it is fine, and this method will be invoked. Understand? And the last argument also, second argument is also you are passing like a 10 only. But that second argument is accepting for this particular method itself. Tell me. So in this case, if you are passing like this, what you will get? Because of for one method, first argument will be matched. For the second argument, second method is getting matched. If this is the case, obviously we are getting, obviously the compiler is getting what? Which method will be executed? Immediately Java compiler is giving you compile time error, sir. Immediately Java compiler, ambiguity error, confusion. Java compiler is giving you confusion. The method m1 int float is ambiguous for the type test2 itself. In this way, we need to understand. In the same manner, obj.m1 of 10.5 comma, okay, 10.5 f comma 4.f, meaning that you are passing two float values. One is matched to here, and the second argument is matched with the second argument of the first method. But still, again, Java compiler is giving you ambiguity issue itself. It should not be like that. If you really wanted to like what pass or invoke any method, exact match supposed to be happen. Otherwise, we are getting the compile time error saying that ambiguity issue. If it matches exactly, it's supposed to be matched. Otherwise, we are getting the issue. That is what we need to understand. Okay. So one more point. So this is whatever so far I'm saying with respect to all these things, whatever the values you are passing, all these are what? Primitive types. These are the primitive values itself. Here I'm writing compile time error. While you are working also, you just try to like what refer it. Compile time error. Okay. Let me Control C, Control S. I'm just taking as the backup case. Okay, different cases we have. This is the first case. Okay, like that you just try to like what remember. So now one more with respect to method overloading. Okay, so whatever the value so far I am taking, these are all the primitive types. So now what I will do is I will try to like what take some object types. Okay, one second. One second, sir. Sorry. One second. Okay, sir. So now I am defining one method, okay, where M1 method is accepting object type, where object is the superclass as we are already aware. System.out.println of object, okay, object class. Anything you can write something like this. Okay, simply you are writing one SOP method, one SOP statement. That's it. So now I am going to like what overload this method. Public void M1. I am just taking string as the type, simply system.out.println of, here it is a string class, simply I'm writing and one SOP itself. So here after you create this object, obj.m1 of new object, meaning that you are passing the object of the object class. So exact match is there or not there? Yes, it is there. My M1 method is also accepting the object class object only. That is the reason this object class will be printed. When I'm trying to print this, object class will be printed. And now obj.m1 of, okay, new string of Rama. Let me save this. And when if I run this, it will give you the string version. Okay, string and then object class, both are working fine. Both are working fine. Now my point is, for example, my point is here. One second. My point is here. Okay, here obj.m1 of, if I am passing null, okay, where null is also a kind of object, right? Where null is also kind of object only. Okay, we are assigning, if there is nothing inside an object, we are assigning it to like what? Null. We are assigning it to like what? Null itself. Just a second. One second, sir. Okay, sorry for the inconvenience. So okay, so here I am passing the object of object class, then it will be executed. I am passing the string object, then this mother will be executed. But now I am passing null. If I am passing null, so obviously here what is the relation in between object class and as well as what? String class? For any class, object class is acting as a superclass. If that is the case, string class is the subclass. Now if I am passing the null, if you are passing the null, it will give the chance. Is there any exact match? No exact match is not there. But now it will give the method overload. The Java compiler will give the chance to like what? The superior class or subclass, parent class or child class. This is my question. So any guesses? So if this is the case, what we need to understand is, if I run this application, what we are getting, tell me here, string class, meaning that Java compiler will be matched with the subclass or parent class. Okay, if there is no exact match with that particular corresponding object, Java compiler will give the chance to the subclass object only. That is the reason we are getting this SOP. We are getting what? This SOP. Okay, so control C. Okay, this is also case, one more case. This is also one more case. You need to understand. What is the note point? Tell me. If exact match is not there, Java compiler will give, okay, will give the preference to subclass version, that is a string. That is what the method, that is the method which is accepting string as an argument. It is not only with respect to string and an object, sir. Any parent child, take any parent child relation related objects, then it will be work out. Not only with respect to object class and then string class, I'm not talking. It will be applicable for any parent child relation kind of classes and objects. Okay, in the same manner, I have got one doubt actually. Sir, if whatever the here object is there, string is there. Now, if there is no relation, what will be happen? So that is also one different scenario, right? That is also one. All these are the different scenarios with respect to method overloading. Just like that, if you are performing this, it will become, again the issue. For example, what I'm saying here, let me remove this. As per that, here also I'm just removing this. Here I have one method which is accepting string. Okay, and I'm having one more method, public void m1, and which is accepting string buffer. Sir, whatever I'm passing here, string buffer, object, all these are the predefined classes available in java.lang. All these are the predefined classes available in java.lang package. Okay, string buffer SB. Okay, my method name is same, but what I am changing? I am changing the arguments. Previously, my arguments were primitive types. Right now, my arguments are object types. That is only the difference. Okay, so system dot out dot println of, okay, string buffer. Okay, string buffer version. Here it is the string version. Simply I am writing. Okay, string version. Okay, so now here, if you are observing, so can you say like this method is overloaded method? Yes, ultimately yes. So now for this, what we need to understand is after this obj.m1 of if it is a string Rama, if I'm passing, okay, Rama is the string object, right? So that is the reason if I run this application, Java compiler will find the exact match, and if I run this application, we got the string version. Okay, in the same manner, obj.m1 of new string buffer of Rama. Okay, now I am passing string buffer object. If I run this, string buffer version also will be coming. String buffer version also is coming. Okay, now since exact match is there, and accordingly those are going to be executed. Since exact match is there, accordingly those are going to be executed. Now, if I'm passing any other data, for example, like obj.m1 of null, this time, okay, I should ask like this. Previously object is there, string is there. That time Java compiler will give the chance to subclass. But right now we have a string class, we have a string buffer class. Java compiler will give the chance to which M1 method? The M1 method which is accepting as a string, or M1 method which is accepting as a string buffer when you are calling the M1 method by passing the null value. Nothing will be happen. Java compiler will give you the compile time error. Why? Because there is no relation in between string and then string buffer. There is no relation in between string and then string buffer. String is one class, string buffer is another independent class. For these two classes, object is acting as a super class. If this is the case, what we are getting, sir? If this is the case, what we are getting? Immediately it is saying compile time error. That is the reason. See here, the method M1 of string is ambiguous for the type test2. All these points you need to understand. So when we are not getting any error, whatever the methods are there, if the arguments which you are passing, if those arguments have any relation, parent child relation, that time Java compiler will give the chance to the child class argument, the method which is accepting as the child class argument. But this time my string and then string buffer are the two independent classes. There is no relation. If that is the case, obviously we are getting what's a compile time error. Compile time error. This is also you need to understand. This is also you need to understand, right? So that is all about what compile method overloading. Method overloading itself. Yes, we took like different scenarios. So these scenarios are more than enough to understand the method overloading. Just like that, I did not perform these method overloading examples. I took the different scenarios, and these scenarios are more than enough to understand this method overloading. So ultimately, in the entire method overloading concept, whenever you call the method, this method binding or method resolution is happening at a compile time only, based on this reference variable only. We don't require object type. That is the reason this is the eligible. This method overloading is the best example for achieving the concept of compile time polymorphism. Whether it with respect to primitive type, whether it respect to object type, whatever it might be. Okay, this is the compile time polymorphism. Okay, now after method overloading, we have a method overriding is there. What do you mean by method overriding? See, what do you mean by method overloading? Method name is same, but a signature, either type of parameter or number of parameter or order of parameter. And one more important note point is, to perform method overloading, okay, we need, or else, okay, one Java class is enough. One single class is enough, because of inside the single class only we are defining multiple methods with the same name and then changing the signature. That is the reason one class is enough to achieve the concept of method overloading. But in case of method overriding, okay, it is a process of defining method name as same. It is the process of defining method name as same by changing, okay, sorry, it is a process of defining method name as same, but logic is different. Logic is different from one class or from parent class to child class. This is what you need to understand. Meaning is, note point is what? To perform, come on please, to perform method overriding, minimum we require two classes. With the parent child relation. This is the rule actually. So what is method overriding is saying? Sir, here also method name is same in both parent class and then child class. But what is going to be different? Logic of the implementation is different from parent class to child class. Inside the parent class, we have some logic, and inside the child class, we have some other logic. But method names are same. When should you go for method overriding? You may get this kind of requirement. Whatever the existing logic was there, if I am not meeting this, if I didn't meet this particular logic, take the same method and then override and provide new functionality. See, always rate of interest is not same. Okay, so rate of interest is going to be like what, varies. If that is the case, we are not allowed to change the method name. What we have to change? We have to override the method. Just update the rate of interest from 4.5 to 5.5, something like that. Whatever the existing logic was there, okay, if that is not sufficient, or if that is not meeting our requirements, okay, then we'll go for what? Overriding. Overriding itself. That is the case actually why we should go for what? Method overriding. Okay, for example, if I close this already we have parent is there. Okay, already we have parent is there, and then child is there. So you know already how can you achieve the concept of parent, inheritance concept. Inside my parent, sum is there. Inside my child, sum is there, and then child sum. So here, whether you are observing or not, this is giving you child sum, this is giving you parent sum. Method name is same, but what is going to be different? But what is going to be different? Tell me. Method name is same, but what is going to be different? Logic is going to be different. Okay, if you are not understanding what I am doing here, here int, try to understand, int x comma int y, system dot out dot println of system dot, okay, sorry, here system dot out dot println of sum plus of x plus y, save it. Okay, sum plus of x plus y, and in the child sum int x comma int y. In the child class, I am defining the same methods, but I am performing the difference or multiplication plus of x into y. So your parent class is giving you the addition, but your child class is giving you the multiplication. That is the logic. But in the both the cases, my method name is same. Both the cases, actually some method should not give the multiplication. That is not make sense. But just to understand, I am giving you. My parent class sum method is giving you the addition. My child class sum method is giving you my sum, or else OP. I am just giving you OP, or else operation. So here also I am performing operation. This is the method name. Don't get confused with the method names also. My parent class contains operation is the method which is giving you the addition. My child class also contains the same method which is giving you the multiplication. So now tell me, in the test1.java, what I am doing here? In the test1.java, come on please, in the test1.java, okay, now I supposed to create an object of child class, child obj equals to new child. Save it. obj dot sum of, sorry, obj dot operation of int comma int it is expecting. Okay, for example 4 comma 5 I am passing. So what we are getting, tell me. If you are, so you may create the object for the parent class, you may create the object for the child class, something like this. Now it is highly recommended to create the object for the child class only whenever you are applying the inheritance concept, as I told you. Okay, so if that is the case, it will give you the multiplication, or it will give you the addition, what you are expecting, because since you are creating the child class object, control goes to here, and so it will look for, if we are getting the multiplication, meaning that your parent class method is overridden. So here, this is what's a overridden method. This is what original method. Parent class method is overridden method. Child class method is what? Overriding method. So try to understand the terminology or vocabulary. Okay, don't get confused. Our original method is available inside the parent. This is the existing logic that is giving you the sum. My child class require different logic, that is multiplication. So if that is the case, if you run this, you will get the multiplication only, that is what, 20. You will get the multiplication only, that is 20. If you are getting the 20, meaning that existing logic will be replaced, will be overridden with the new logic or not? Yes, that is how exactly is happening. For example, by mistake, you are trying to override the method of parent class. Okay, but the method name is operation, O should be small. But by mistake, but your intention is to override, but by mistake you are giving like this. Okay, you run this, but what is you are expecting? You are expecting the new logic, that is multiplication. But when you run this, you will get the sum. Arey, why like this? Why it is happening like this? Because by mistakenly your operation, okay, method name, you gave like O as what, capital letter. But your intention is what? You have to override the method, that is your intention. So it might be happen something like this while you are doing or working in the real projects. So to avoid this, whenever you are going to override the method, you please try to like what, add this annotation on top of this overriding method. Whenever you are using override annotation on top of the overriding method, if any spelling mistake went wrong, immediately we are getting the compile time error. Anna, you are trying to override the operation method, but you gave spelling mistake is a small O you have to give like this, like this. Okay, instead of getting the runtime issues, we are getting the, instead of getting the wrong output, if we are getting the compile time errors, there itself only we are able to cross check and then we are able to fix those things. So in that way, this annotation is helping. That is the reason it is highly recommended to use at the rate of override annotation on top of the overriding method while you are overriding. Okay, if any spelling mistakes are going wrong, so those things are coming with respect to compile time errors only, so that we can fix those issues at compile time only. Instead of getting the wrong output, compile time errors are better, na? Far better. Compile time errors are far better than the giving the wrong output itself. So that is why we have to like what, use this override annotation itself. Even though if you are missing any spelling mistake, immediately it is giving you the compile time error. And check your spelling mistake, something like this. So this is what we need to understanding regarding about what method overriding itself. So note point is, it is highly recommended, okay, to use at the rate of override annotation, okay, on top of overriding method, meaning that in the child class context, overriding method. Okay, so yes, this is highly recommended. So accordingly, I'll give you this example also. I'll give you this example. So just wait here. Parent.java. We need minimum 2 classes. Okay, with parent-child relation. Otherwise, we can't override. We can't override. So what do you mean by overriding? Method name is same. The entire method signature is same. But what is going to be different? Logic is going to be different. I don't want the existing logic. I want a new logic. And then take the same method and then change the logic. Okay, that is the meaning of what? Overriding. Okay, come back to like what, child.java, control C. Okay, so control V. Here it is a test1.java. Test1.java is your execution logic class, because there itself only I am defining the main method itself. Okay, control C, and here control V itself. Let me save this. Here one more point I wanted to tell you. Here one more point I wanted to tell you regarding overriding only I am speaking. Regarding overriding only I am speaking. Okay, we have many points are there, but I don't want to talk all those points right now, because I just want to like what, speak about what overriding rules. Do we have any other rules are there to perform the overriding? For example, here, 1 second. Is this possible? Okay, 1 second. One second, sir. Okay, so okay, this is one thing, right? So in this way we are able to like what, override the method. Okay, but while we are overriding the method, we have some rules are there. For example, here, if it is a private, if it is a make assume, sorry, not here, it is something like public only, save it. Okay, in the parent we already have one method is there, operation, with respect to like what, public access modifier. But while you are overriding the method, okay, is it possible to like what, give private? No, we are getting the compile time error. Is it possible to like what, give the default? No. Is it at least giving the like what, protected? No. Meaning that, okay, but If it is a private, okay, while you are overriding, you can use public. Okay, you can use public. If it is a private, while you are one second, why the error is coming? Okay, parent.java. Here it is private. Okay, so why we are getting this error? Because yes, whenever you are defining any method with respect to private, okay, in the child while you are performing, what is this? Tell me. The method operation of type child must override or implement a super type method. What is this? One second. Here, did I do anything wrong here? Operation, Control C, Control V, save it. So now what is the error we are getting? Must override or implement a super type method itself. So meaning that private methods are not participating in overriding. Private methods are not going to be participated in method overriding. Once you define the method as a private, first of all, it is those properties are not going to be inherited. If those properties are not going to be inherited, how can you override? There is no concept something like that, right? There is no concept like that. That is the reason private methods, very important note point. Private methods can't be overridden. Can't be overridden. So if you are trying to overridden, you will get what? Compile time error. You will get what? Compile time error itself. So something like new compile time error is giving you. But okay, one second, let me remove this, save it. Okay, now the error is gone. So private child here, let me try to, one second, the error is there. Here also private, save it. Still that of operation int comma int from the child is never used locally. One second, yes. Here we are getting the error itself because we are not getting any compile time error, sir. So inside my parent we have a private method. Inside my child also we already have a private method. Same thing. Your child class method is giving you multiplication. Parent class method will giving you sum. But the method is what right now? Private. In the child, immediately when you keep the cursor here, the method operation from the type child is not visible. You're not able to access. You're not able to like what? Access that from outside of the class. Because of that is what? Simply, the private. So that is the reason private methods can't be overridden. Private methods can't be overridden. Okay, private methods can't be overridden. And do we have any other rule? Do we have any other rule? Yes. For example, if I'm defining like a private, okay, so or else, for example, right now it is something like protected. Assume my parent class method is what? Protected. So in the child class, while you are overriding, okay, while you are overriding, if you are removing this, still we are getting the error. Why we are getting the error? Because okay, the order of access modifiers. First, it will start private is okay, rs private is less than default. Default is less than protected. Okay, and protected is less than public. So this is the order, right? So if this is the order, while you are overriding the method, you can increase the scope of or visibility of the modifier. You can increase the access modifier visibility. If protected is there, you can make it like a public. You can make it like a public, and then error will be gone. But you are not allowed to decrease the scope of the visibility. If already protected was there, if your nothing is giving, that can be treated as what? Default. That means you are trying to decrease the scope of the visibility. While you are overriding the method, we can increase the scope of the visibility, but you are not allowed to decrease the scope of the visibility. If any private is there, you can use protected or default or public. But if there is any public in the parent method, it should be public. Okay, if it is available inside the public in the parent, in the child class, it should be public. If you are using protected, also it is giving you error. If it is a default, also it is giving you error. If it is a private, also it is giving you error. You should not We are not allowed to like what decrease the scope of the visibility while you are overriding the method. This is also one thing you need to understand. Okay, so note point is while we are overriding the method, okay, it is always, okay, it is always possible to increase the increase the uh, increase the visibility scope, not to decrease, not possible to decrease the scope of the visibility, not possible to decrease the scope of the visibility. Okay, you know the order, right? So private is less than, default is less than, protected is less than public. This is the order. You have to like what keep these things in your mind while you are overriding the method. And with respect to final methods also, I wanted to talk final methods also. While you are overriding, you have to like what take care. You have to like what take care. For example, inside my parent, okay, public final void operation is there. Is this possible to like what override? I mean, am I able to like what override this? Okay, final to non-final I am trying to change. Immediately we are getting the error. Overrides cannot override the final method from the parent. Cannot override the final method. Once you define any method as the final, while you are overriding, okay, while you are overriding, I mean, final to non-final, it is not possible. Final to non-final, it is not possible. That is the reason, okay, final methods cannot be participated in overriding, cannot be participated in overriding itself. These things you need to understand. But okay, for example, there is no final, okay, inside my parent class there is no final, but in my child class, am I able to like what make this one as the final? Am I able to like what make this as the final? Yes. So meaning that while you are non-final to final is possible, while we are overriding, but final to non-final is not possible while you are overriding. But final to non-final, okay, not final is not possible. Okay, these things. Final means what, sir? It is a constant. Once you define anything as the final, it is a fixed. You are not allowed to perform any other changes. That is the meaning of what a final. Once you are defining any method as the final, it is not going to be participated in method overriding. But in my parent class, if any not final methods are there, those things also you can override. But while you are overriding, you also can use this final keyword. That is not at all giving you the issue. These are all the things you need to like what keep it in your mind while you are performing the method overriding. So method overriding, especially okay with respect to okay exceptions, we do have some rules are there. Those rules I'll tell you little later. Okay, those rules I'll tell you little later. But before, because exception handling concept is required. Exception handling concept is required. That is the reason. Okay, that is the reason exception handling concept is required. That is the reason I'll tell you later itself. And here one more point I wanted to tell you here. Okay, if you're observing operation, parent class method is giving you the sum, child is giving you, let me remove this final keyword, child class operation method is giving you multiplication. In the test one, this is fine, right? You are creating the object for the child class and you are calling the operation and it will give you the multiplication. When you run this, it will give you the child class logic. That is what multiplication. But now if I am giving parent obj1 equals to new parent, okay, new parent, that means you are creating the object for which class? Tell me. Parent class. If that is the case, obj1 dot operation, okay, 3 comma 4. So since you are creating the object for the parent, okay, so it is going and then checking for the operation inside the parent class. Okay, when I try to run this, it is giving you the addition. But now one more important point I wanted to tell you, that is the third case, parent obj2 equals to new child, meaning that I am creating the object for the child class, but I am trying to hold in which reference variable? Tell me. obj2 of which type? Tell me. Parent. Meaning that, are we able to store the child class object inside the parent class reference variable? Yes or no? Yes, sir. We do have a object typecasting is there. Already we had a discussion at a primitive level. Okay, primitive level just now in the method overloading also I told you. Primitive level we have already seen the typecasting, but object level typecasting, we have a downcasting is there, we have a upcasting is there. Whatever the casting I did here, I am converting the child class object into parent class. I am converting the child, I have a child class object here, I am converting and then I am storing inside the parent class reference variable. So converting child class object to the parent class object is known as upcasting. Upcasting automatically done. Yes, you don't get confused, sir, because we have a separate concept is there, object typecasting. I will tell you again, but ultimately what is your important point here is, you please try to remember, are we able to store the child class object inside the parent class reference variable or not? Yes, it is possible. This concept is known as upcasting. Upcasting is automatically done by Java compiler implicitly. We no need to do explicitly do that. Okay, once it is fine, you know already, right? We can write this in two statements. One is like this, and the same obj2 equals new. This one is what? Reference variable, I mean declaration, and this one is what? Referencing. Okay, now obj2 dot operation 3 comma 4. Tell me, at compile level Java compiler will check for obj2 dot operation. Okay, inside the parent, since obj2 is of parent type, operation method is there or not there? There, sir. So that's why it won't give you any compile time error. That is the reason I'm not getting any compile time error here in the 17th line. But which class object, I mean which logic will be executed? Parent class operation method or child class operation method? Parent class operation or child class operation method? Sir, that will be decided based on the object type. Which object you have created? Child class object. That is the reason it will go to this child class and it will execute this overriding method. It will go to this child class and it will execute this overriding method. So if that is the case, what output you are expecting? Sum or multiplication? Obviously, it is giving you the multiplication only. So ultimately, my conveying point is here, it's very simple. When you create the child class object and storing it into the parent class reference variable, on top of this, if you call the method, based on the reference variable, method resolution is not happening. Based on what it is happening? Based on the object type. Based on the method resolution is going to be happening based on the object type, sir. Based on the object type, not based on the reference variable. If it is happening based on the reference variable, which one you will get? Multiplication or sum? Sum only. So why we are getting the multiplication? Because of this method resolution is going to be happening based on the object type. So then control goes to this child class, and whatever the overriding method is there, that will be executed. You may ask one question, the same kind of scenario we are also getting by using this kind of scenario, na? Even if you are creating the parent and then new child, this also will give you the same output, and whenever you create the child class object also, it is giving you the same output, right? Okay, but here one important, with respect to child class object, you are able to access the overriding methods, and as well as what? Child class specific methods also. For example, sir, inside the child, okay, we have something like this are there. For example, assume public void, okay, public void child is the method, or else public void m1 is the method is there. Assume system.out.println of child specific method. Okay, this method is available in the child class. This is not available in the parent class. In the test one, with respect to the child class object, obj dot m1 also you can call it, and when you try to run this, you will get that m1 method also. See here, child specific method. But when you are using this approach, okay, using this you can't access obj2 dot m1. Am I able to like what invoke this m1 method, sir? The method m1 is undefined for the type parent. Why? Because right now my obj2 is of which type, sir? All of you tell me. Parent type. So compiler will go to the parent class and it will look for the m1 method. f1 method is there or not there? It is not there. Immediately it will give you what's a compile time error. So with respect to this particular scenario, what methods we are able to execute? We are able to access with this reference variable, we are able to access only the child class overriding properties. Overriding properties. Using this scenario, we are not able to access the child class specific properties. That is the difference between this approach and this approach. I hope you got the clarity. Okay, so this will give you what? Compile time error, because obj2 is the reference, is a parent type, but inside the parent class m1 was not there. That is specific to child class. But that is the reason it is giving you what? Compile time error itself. So I hope you understand this particular scenario also. But whatever I said, the third scenario, it is very, very important. Okay, this is what? Very, very important. It is a runtime polymorphism. Runtime polymorphism. How can you say this is a runtime polymorphism? Because of not based on the reference variable, not based on the reference variable. Okay, that method resolution is not going to be happening. Based on the object type which is going to be created at runtime, this method resolution is going to be decided. That is the reason this is the best example for what? Runtime polymorphism. This is the best example for what? Runtime polymorphism. So first of all, method overriding itself is the best example for what? Runtime polymorphism. But I will clearly show you here with respect to this scenario or approach. This approach is telling you what? It is the actual runtime polymorphism. Based on the object type, method resolution is happening, not based on the reference variable. Okay, and the two object will be created at runtime. That is the reason this will be considered as the runtime polymorphism. Right. So I think in the parent.java control C, okay, runtime polymorphism. Okay, method resolution can be happened, okay, at runtime based on the object type, not based on the, okay, reference variable. Okay, so that is why it can be considered as what's a object, runtime polymorphism. Okay, let me copy this. Parent.java, you have to practice child.java. In the child.java, let me copy this. Control V. Here it is a test1.java. Right. Very, very important points. Today we had a discussion on top of this compile time polymorphism and runtime polymorphism. Assignment I am giving you. Okay, try to override the static method. Okay, so this is one assignment, meaning that inside the parent class define one static method. Okay, inside the parent class define one static method, and that static method try to override inside the child class, and observe whether it is really getting overridden or not. If it is really getting overridden, you will get the child class. Otherwise, you will get the parent class logic. So this is one simple assignment I am giving for overriding the static method itself. Okay, so thank you.